Thank you and welcome to everyone. Today, as Andreas mentioned, we'll present how we do the data capture here at Beak. So this is a simple workflow, how we start doing that. So we have the layers that are previous maps, and then we start using our equipment and technology to provide these useful insights like LiDAR, multispectral RGB, or thermal imaging. So these are the two user case scenario. The one on the left is the parts from Mecklenburg-Vorpommern, and the other one that is on the right is Brandenburg landfill volumetric survey. I'll leave it here. Okay. Is it good? Hello. Okay. So the first goal of the first project was to capture high-resolution drone imagery and LiDAR. So we needed to generate a high-detail terrain model and update the orthomosaic for the digital federal waterways. And we chose, because there are 3 areas and like 10 kilometers each, we chose to do another flight. It means that is the camera and the sensor is pointed 90 degrees. And we choose for this case to do a corridor mapping instead of like normal polygon mapping that is done. And we planned it using GCPs to have consistent measurements all over the area. So in the 3 different AOEs, we put 2 pairs of GCPs, one part for orthophoto and the others for the LiDAR. And this mission was, each of these corridors were split in 1 kilometer sections so that we could have a robust anchor to the ground, so that will be no drifts to this type of surveys. So the photogrammetry, because the client was specifically asking for the photogrammetric mission to cover a wider area, like 400 meters from the waterline. And the LiDAR was closer, like 100 meters, what was happening around. So we used different overlaps for both of the flights, and you can see in different flight altitudes to achieve these accuracies. Okay, so these are the equipments that we used and what we used to do the geospatial positioning. So we are using currently here at Big the Matrice 300 drone with a LiDAR that has also an RGB, that is the DJI L2 LiDAR system, and again with a GPS system. So in case of this project, we use the 2 methods for positioning. RTK, that is the real-time kinematic that we receive corrections and for the GPS in a real time. And just in case we had a PPK positioning, that is post-processing, we logged all the GPS data that were available in case of any misfunction on the VRS or on the N-trip service that was offered from the state. So the LiDAR processing is like a normal, simple LiDAR processing procedure. What we did here is like the trajectory alignments, point cloud classification, that is the most important part. Before we start, we clean out the noises and everything caused by this high vegetation area. And there is, let's say, minimal bare earth to be seen from above. So we use 5 returns of the laser from the LiDAR to get to bare earth conclusions, and everything was digitized in 3D using this RIDALI standard, that is the standard for waterway drawings. And we produce at the end like this digital map to the 3D models, DDM and DCM models. Here you can see on the top left the digitizing of bridges and any other things. So we use this method that we digitize in isometric view in the software and use also the cross sections views on 2 different directions, that we are sure that we have everything on top of the surface and not like going around and disturbing. So we achieved in this project 300 points per square meter. That is a quite dense point cloud, let's say. And at the end, we delivered 8 point per square meter because nobody can open it. If it's like more than 300 points, you cannot work with it anymore. And we managed to achieve a vertical and horizontal accuracy of 2 to 3 centimeters. So the client was asking for 5. So this is a good point for us. Okay, the second case study is the Deponie Scheinhöscher landfill in Brandenburg. Here, the goal of the project was to update yearly, and this is an ongoing project to update yearly the maps and as-builds of this plant and the active deposit that need to be calculated every time for volumetric monitoring. So, as in the other project, it was high precision topographical digitalization. And the new thing here is that is dynamic topography mapping. So the structure changes over the years. So we need to be as consistent as possible with every measurements, and everything need to be at the same point. And we needed to deliver as-built drawings in 3D and 2D maps for their applications. So in this project, we use photogrammetry only. It was asked by the client to use only photogrammetric mission planning. So it was the same equipment as we used before. In the left bottom part, you can see a schematic figure showing how everything is connected to each other, the drone, the GPS, the base station, and the benchmarks that we had on the bottom part. How can I point? Can I point here? Like this? Okay. So here we had a benchmark that it was there for many years. So it was to check all the deponie or the landfill to check for depressions and if it moves because it's an active area. So what we did is we created a network of points, like triangulation points for the GCPs, and some of them are on the active area and most of them are outside the active area. So we can have as much as possible consistently during the year. So this is a 4-year monitoring that will be updated every year, and we need to update all the volumetrics and all the drawings. So here is what we did exactly. Here is the digitalization in 3D in the isometric view, how it goes, roads and different elements. As you can see here, the buildings were extracted automatically using from the point cloud classification, and we extracted most of the break lines automatically also from the classification of the point cloud. And then the other part was done manually because it cannot be done on the top right. Here, this is the triangulated model of the whole area, and this is the active part, as you see, this blue part. And yeah, this is just showing how the method that we use to do this type of 3D modeling. The volume calculation, so we needed to do yearly. We need to do 2 types of volume calculations. This is just one of those, the second one, the end cubature that it should be. So they have a project, how much deposit they can put there, and we need to calculate how much they have left to fill in or to cut on some other areas. But we do also another one that is total landfill mass, that is the total changing during years. So here we use the method that is direct to direct surface comparison, not profile, that is usually done in engineering works. So the numbers are fictional, it's just for showing. And we saw different things during this type, but they are not shown in the images. We saw also depression because this is a waste mine, and because of the waters that run through, we could see depressions on the ground and like 10-centimeter depressions that are concerning for the client itself and for the structure stability. And yeah, here is a short overview what products do we offer here at Beak, starting from engineering survey, mining monitoring. We can do this corridor mapping, as I showed you, but not only for waterways, but we can do it for power line inspection and for other type of related engineering objects. So we do land surveying, is obvious. Forestry mapping, we can do it using remote sensing satellite data analysis, or we can use the drones itself to try to calculate the biomass of trees or count them or do forest management. Thermal mapping is a new field that we are approaching with this, especially for solar panels to do monitoring and annual inspection. We can do also change detection and multispectral imaging. We had a project a year ago that we were doing multispectral imaging for precision agriculture case studies.